I'm going to cover how to do two different kinds of regressions in Jamovi. Regression is a technique where we plot a line through a scatter plot. So let's look at the data first that we're going to predict. I want to explore the relationship between GPA as an outcome and backward digit span as a predictor. And if you look at the linear regression through here, right, there's a significant relationship between these two. If we look at the scatter plot, they're correlated. Regression, a single regression, allows prediction. We can eyeball this with a line. If somebody scored a backward digit span of 4, if you go up to the line, you would expect a GPA of about 2.5 because that's where the line hits. Right? Go up from 4, 2.5 is the GPA. If somebody scored a backward digit span of 6, on average, people with a backward digit span of 6 have a GPA of a little above 3. If somebody had a backward digit span of 8, they tended on average to have a GPA of 4. We can eyeball this off the graph, or we can use the regression equation to do this for us. It plots the slope and the intercept. So we'll do that under regression. We're going to do a linear regression. Our outcome is GPA, it's our dependent variable, and we're going to use digit backward as our covariate to predict it. We can see the R was the same you would get if you ran correlations, 0.704. The R squared of 0.496 tells us that we're explaining about half the variance in GPA. Half is unexplained by our model. And what we're looking for here is the intercept is at 1.3, and we can see the effective digits backward, and we're looking here at the estimate 0.376. That 0.376 is a slope. Slope is the amount of change in y associated with the change in x. Think of this like the yield in a vending machine. If you put in $1, you get 40 M&Ms, a slope of 40. If you put in $1, you get 1 bottle of Coke, a slope of 1. So it's how much comes out when you put a single thing in. So when we put in a single more digit backward, we get an increase of GPA of about 0.376, of almost 0.4 increase in GPA. And we can see that's a significant predictor. We look at the t and the p-value to tell us whether or not that predictor is significant. So single linear regression gives us the y-intercept, it gives us the slope, and it tests the significance of those values. Notice this only accounts for half the variance. We can run a multiple regression and start adding factors to try and increase our R-squared. Most things in the world don't have one causal factor. Most things in the world have many factors. Think about your weight. It's the amount of exercise. It's the amount of ice cream you eat. It's the amount of potato chips you eat. It's the amount of lettuce, kale, and vegetables you eat, right? There are multiple predictive factors. So I can start adding predictors in a multiple regression. So I can take backward digit span, forward digit span, and I can even add age. Because I have multiple things in here under coefficients, I'm going to ask for standardized estimates. That applies the z-distribution to them so I can compare them. Age is a very different variable than digit span. And comparing the two directly is an apples and oranges comparison, which is why we ask for standardized estimates. If you look at the R-squared just went up from 0.49 to 0.527. So we're accounting for more of the outcome by adding in more variables. If you look at the coefficients at the bottom, look at the significance tests. Right? We have digits backward, digit forward, and digit and age. The intercept is the unexplained variance, and the y-intercept on the graph. The thing to look at here are the p-values. Digit backward at 001 is the only significant contributor to differences in GPA. Right. The standardized estimate is 0.57. The plain old slope is 0.30, right? That's the put in $1 to the Coke machine, get 1 Coke, put $1 into the M&M, the slope is 40, you get 40 M&Ms in the bag. Right? So slope here is still 0.3, close to what it was when we had the single regression, a single factor. That when you put in an extra 0.3 digits back, an extra 1 digit backward, your GPA goes up by about 0.3. You can see digits forward is not a significant contributor, and age is not a significant contributor. The neat thing about the standardized estimates is they're directly comparable. The largest factor on the table is digits backward at 0.57. The other two non-significant contributors don't have estimates nearly that big. So we looked at two kinds of regression. We looked at a simple linear regression with a single predictor, and we looked at a multiple regression where we have multiple predictors of an outcome. And the only additional statistic we had in here was a standardized estimate. There's a lot more to regression. There are entire classes on this. This was just basically how to run a simple regression in Jamovi.